In this lesson, we are going to be learning about the internet. So, what is the internet and what can it be used for? Just have a pause the video and have a quick think about the things you use the internet for, and then we'll move on. So you see what you wrote later. So, in this lesson, we'll define what the internet is. We're going to talk about how data travels between computers across the internet and describe the keywords protocols, packets, and addressing. We have a video here that sort of explains what the internet is, and there will be a link to that in the classroom. And so just keep thinking through, what is the internet, what do we use it for? So in terms of the answers to that, the internet is a worldwide network of computers. It is the physical hardware, cables, routers, and other pieces of hardware used to connect devices together, which are owned by all sorts of different people. Any device connected to the internet is part of this network. So your laptops, games consoles, PCs, phones, tablets, these are all part of the internet. We use it for all sorts of things, storing information in the most general sense, i.e. on the cloud, films, videos and music as part of entertainment, playing games, general communication, social media, email, shopping, and just viewing websites, banking. We use it for basically everything these days. And if we know that the internet is a global network of networks, how do you think that the networks in the UK are connected to the networks in America? Have a think about how physically is that done? And then unpause. So they are connected via underwater cables. If we click on this link, I'm going to try and open that now. See if the school internet's up to it. We've got this submarine cable map. And yeah, cookies, fine. So these are all the underwater cables that the internet traffic goes through. So they're fiber optic cables, which are the sort of cables you need for that high performance, high throughput traffic, big bundles of fiber optic cables. And here are all of the names of those cables. So they each have names. And you can sort of click on one and get details about it. Tells you how long it is, who owns it, and there is a URL for it as well. We happen to pick a really tiny one that just crosses from one lake to another. I say tiny, that's probably, yeah, it's 59 kilometers, it's not that small. But yeah, so it's all fiber optic cables. So the first oceanic cable was laid in 1851, which just seems incredibly long time ago. 99% of the internet data goes through these undersea cables, and they get damaged by anchors and even shark bites. I can't imagine they look very tasty, but yeah, they certainly get damaged by anchors dragging them and stuff because they're just underwater. And the longest network, the longest undersea cable, 39,000 kilometers. So it's probably got a lot of repeaters along it. So we're going to be talking about packets. In the previous lessons, we looked at the internet and its 27 billion devices, a number that is probably already out of date. How does a message get from one computer to another? And so you're going to watch this video to find that out. So and that will be linked in the classroom as well. That'll be the second video. So in terms of a summary of that, when you send a piece of data from one computer to another across the internet, it gets broken into packets because a single message is probably too big to fit into one packet. So it gets broken into many packets. If you were sending like a game or just a video or a document, it will get broken into packets. And each packet is going to make its own way from computer to computer across the internet. Each packet contains a bit of the actual data, but then it also contains the address. So if you imagine you wanted to send a book to somebody, like a physical book, you could, it's not ideal, but you could tear each page out and send each page in a small envelope, and each envelope would need the address. And so those pages are like the packets. They come together to form the book. And so in the internet land, these addresses are known as IP addresses. And they are unique globally on the internet, although there are kind of private networks, and there's a whole different thing. So this is what IP addresses look like. If you're talking about a global IP address, it's unique to every machine on the internet. So your house will have an IP address. The machines on your local area network, they will have like private IPs. Those are not unique in the world, but your house will have an IP address, and this is what they look like: 4 numbers separated by a full stop, or at least this is what IPv4 looks like, which is still in use. IPv6 looks rather different, but these are the IP addresses you actually tend to see. And the address of the router, that's like the address of your house. So your IP address, if you search that on Google, you will get given an IP address, and you can give that a try. I'm going to try that now. What is my IP address? Okay, and there's my public IP address. So that's what I present to the rest of the world as. That's my IP address. Okay, so packets and routers. So the green square blobs on here are routers, and routers are used to kind of glue the internet together. That was Siri. And packets get sent across the internet, and they all take their own path. And so if there's one starting here on the top left, it's going to make its way to a router, and it's trying to get there. So it will pick a path down. Each hop of the journey, it tries to find the next router to go to get to where it's going. Their packets will be sent in the correct order, but they have numbers on them because by the time they get to the far end, they will be out of order, but they have packet numbers on, and they get reassembled because they can take different routes. So they arrive in the wrong order. So if the packets have to have those numbers on them, so if you took a book and tore it into pages, the page numbers effectively allow the person to reassemble the book. So here we're going to show a message with a piece of text: hello, how are you? So hello, how are you? That's too long for one packet, so we break it into 4 packets, and we're going to name each of one of those: packet 1, packet 2, 3, and 4. When they get received at the far end, you have them. Packet 1 might get there first, then 3, then 4, then 2, and so they have numbers on them in order to tell the far end how to reassemble them. So this is what a packet looks like. There are other bits and pieces, but at this point, this is all we're going to be looking at. So you've got the sending IP and the receiver IP. So these are the addresses of the person sending the message and the person who it's designed to reach. And then it has a sequence number that says, right, this is like the first one of like 5. And then there's the payload. So the payload is the actual data we want to send. All this other stuff is just so the message gets there. In the same way as when you send someone a letter, the envelope is not actually what you're trying to send them. You're trying to send them the bit inside, but you need the envelope in order for it to actually get there. Here's a 3-packet message, and this is each of the packets has the IP addresses on, so it's the same. And then they each have a different sequence number, which lets the far end put them back together. So you have a worksheet which is in under the task A1 worksheet, and this is the only bit of worksheeting I shall do. So first thing you're going to do is just go onto that cable map and find the 2 countries that are joined by that cable. So you should be able to find the Columbus 3. If I go back, you'll have to. There you are, submarine cable list. Columbus 3, just find it, click on it, get those details and type them in there. It will tell you how long it is, kind of showing you where that is. But packet ordering, what you need to do here is fill in the blanks. So there's a blank here. What's that sending IP going to be? Well, it's going to be the same as all the other ones, right? Because this whole message is for the same end. And then you're going to put the payloads in, the sequence numbers as appropriate. So the idea is you fill this in to create 4 valid packets. And that's the bit on the worksheet. They're the answers, but I'll skip over that for now. So, protocols. We talked about protocols before. The protocols, there's TCP and IP. So TCP stands for Transmission Control Protocol. IP stands for Internet Protocol. So protocols, remember, are rules governing communication. And so TCP and IP tell devices how to make up packets, what packets need to look like, what do they need to contain, how big are they allowed to be, what does an address look like. These are all part of the rules. So TCP, what TCP does is is the protocol for splitting it into packets. It splits the message into pieces, and at the far end the sort of reverse of that protocol, put them back together again. The IP protocol is used for the routing. The IP protocol defines the format of the addresses. Okay, so it's actually two separate protocols, and these are kind of organized into layers. So there are a series of questions which I'm going to get you to do in a quiz. And there's a homework. It's all in one quiz. So if you have done the worksheet on forming the packets, and then you're going to go do the quiz, which is going to be under, here's your class internet quiz. Just do that quiz. It's a load of multiple choice questions. The answers are all in what I've been talking about. And then we've done the internet. So have fun with that. Make sure you hand your work in when you're done.